Hello everyone. I'll be starting with the session now. So, dear authors and invited guests, welcome to Technical Session 7D. My name is Dimahi Patel and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, London, United Kingdom. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom from 19 to 21st February 25. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it out to me in chat box. Now, just before we start the session, I would like to introduce you all to the chair of the session. We have with us Dr. Kanakan Phanipong. Sir has received his MBA degree in Business Administration in 2008 and DBA degree in Business Administration in 2018 from Pathumthani University, Thailand. He is currently a lecturer at the Faculty of Business Administration and Information Technology at Rajamangala University of Technology, Bangkok, Thailand. Sir, we welcome you to this session and I will request you to share a few words to the presentees that we have here today.
So, welcome to a great conference in my opinions, and I hope you everything can share to the contribution as well. Then best good luck.
Thank you, sir. We also have with us Dr. Monica Rathod as our session chair. She is currently an associate professor at Manipal University, India, and has over 15 years of MCA teaching experience. She is a research supervisor at Rajasthan Technical University, Kota, and she has currently 6 students pursuing PhD in computer science under her supervision. Along with more than 20 research papers of hers have been published in reputed journals. We welcome you, ma'am, to this session, and I would request you to share a few words to everyone present here.
Thank you so much, and I'm looking forward for good enriching knowledge from all the authors. So all the very best.
Thank you, ma'am. So now we'll be starting with the presentations. First up, I would like to call upon Huangjo Mena to present his study on augmented reality in early childhood education, the Active Triangle Kids project. Sir, are you present here?
Yes, we are here.
Antonio, will you be presenting on behalf of him?
Yeah, and Adrian Fernandez, that is also here.
Okay. You may start with the presentation. Thank you.
Okay, thank you. Okay, we are going to present our work that is titled Augmented Reality in Early Childhood Education, the Active Triangle Kids project. And this work has been done by Juan Jomena, Juan Miguel Lorite, myself, and Adrián Fernández. And what we have to share, I mean, this is a project that is based on that we have worked in a technopedagogical system that is named Active Triangle Kids. And this technopedagogical system has different kind of characteristics and advancements for education, and we can change and we can focus on different aspects like the technological aspect. And in this sense, this system favors um, the educational part in different sectors outside of education, like businesses and institutions. And it is relevant to point out that we are using emerging technologies like augmented reality and the use of Internet of Things to enhance different aspects of early childhood. In this sense, um, we have considered to use augmented reality because this overlays digital elements onto real world environments. And with this kind of technology, we can use 3D technology for immersive experiences. On the other hand, uh, we have we have considered to create a optical recognition system that enhance the industrial use of this technopedagogical ecosystem and the user experience when they are using it. And this object detection system was made using YOLO, the YOLO algorithm, that enables real-time object recognition. However, the challenges remain in the physical object retention. And well, um, mm, we should focus now on the methodology that we have done to use this. I mean, well, we have designed, as I said before, a game, an AR game, and well, the optical recognition system. These two types of technologies are with the same object, and are different parts of the learning process. And well, we have designed them, we have developed them, and we have used different tools like PyTorch Mobile for the deep learning aspect, and the model SAM for the part of object segmentation. And then, as well as I was saying before, we have used the YOLO-based object recognition. We have started with the YOLO algorithm for the first time because we have considered that this is the best algorithm for object detection based on different studies. However, we started to use the YOLO v5 version, but we have had some problems with it, and after a few tries, we have changed the system to an upgraded version like YOLO v8, and this version is better because it has an improved segmentation. It facilitates object tracking and object classification, and we have used to train the optical recognition system extensive data sets of different images to guarantee the optical recognition. And well, now we have to focus on the AR video game. And to develop this game, we have used different software, like, well, first of all, Unity, and we have implement different kinds of studios to design the game. Finally, we have got the 2022.2.4 F1 version that we have considered that it is the more suitable option for scene and transition development, because our game have this kind of features to explain different activities that are presented to kids. And this is important because this game have interactive avatars that are presenting information, that are presenting activities. They are linked by audio. And we have programmed some buttons to use the game. And we have used other softwares like Android Studio, because we have to link the AR the AR tool that we were used, that is called Unreal, with our computer. To achieve this object, we have used the ADB Wi-Fi plugin to use the option of screen mirroring to guarantee that we can link these two technological pieces and use the video game in a proper way. And well, we have used, like I was starting to say before, the dataset was conformed by 57K labeled images using the model SAM. Then we used the YOLO V8 checkpoint for develop the optical recognition system, and then we had to integrate this model in Unity by using the object detection link. And finally, we've done a proof of concept to verify the usability of the video game and the optical recognition system. And well, these images that we are showing now are, first of all, the one of the left is the original YOLO model that you can use to train your recognition system. And the image that you have on the right shows the process that we have followed and that our recognition system follows to recognize the pieces. I mean, we have a first phase in which this system recognizes only the pieces color, and then a second phase in which this system recognizes the shape, and then we have a third phase in which they recognize the shape, but in a more accurate way. And then we have a fourth stage in which we combine the shape and the color, and it is recognized by this system. And finally, in the final version of this recognition system, we have everything combined, and the system recognizes everything: shape, color, and all of that at the same time.
I'm very sorry for interruption, but Antonio, I would request you to please adhere to the time limit. I would request you to end your presentation soon now.
You want me to end it now?
No, I want you to fasten up your presentation since you're reaching your 12-minute mark.
Okay, sorry. Well, we have got some results like, well, as I said before, the optical recognition system, full design, the the video game, in their best way. And now I'm going to say the conclusions.
I'll say them. Okay, so to sum up, the development of augmented reality applications is valuable across different fields, but this particular project focuses on education. Its goal is to create a simple and user-friendly experience for children from 3 to 6 years of age by ensuring clear object labeling and an intuitive interface. In relation to the future improvements, they will focus on optimizing the optical recognition system for better accuracy and performance, as well as enhancing AR game elements, including transition, scenes, and virtual objects. A key objective is enabling full interaction between the AR game and the optical token recognition system to support educational activities. Additionally, explanatory scenes currently performed by avatars may be replaced with short films featuring real actors. Lastly, the installation process will be simplified as the current need for Android Studio software limits accessibility for potential users. And that concludes our presentation. Thank you very much for your attention. We would be happy to answer any questions you may have.
Yeah, I have a question. What are the main challenges of YOLO in object recognition, which you have already found? Like, what are the challenges regarding the small object detection or any lighting variation?
Well, the challenges that we have encountered were mainly the well, our recognition system didn't recognize. It recognizes only groups of pieces, and it didn't provide specific information for those pieces. So this was our harsh challenge.
Okay. No more questions from my end.
Sir, do you have any questions? Kanakan, sir?
No, I have no question.
Okay, thank you for your presentation.
Thanks.
Thank you.
Now I would like to call upon Strahil Sokolov to present his study on automating medical screening processes with machine learning, improving data quality and reducing human errors.
Thank you very much. I hope you can hear me and can
Yes,
see
sir.
me. I'm sharing my screen now. Okay, I'd like to begin my presentation on automating medical screening processes with machine learning for improving the data quality and reducing human errors. I'd like to first introduce the authors, then make a short introduction to our study. Then I'll talk about the background and motivation. Then I'll talk about the methodology that we have used for the study. I'll show you the workflow description, then I'll talk about the results, and I'll describe the case study that we had during our project. So two of the authors, myself and Professor Radev, are from the Department of Telecommunications from the University of Telecommunications and Post in Sofia, Bulgaria, and our PhD student, who is the main driver of this research, who is unfortunately not here to present today. He's with the medical college at the Trachea University in Stara Zagora. He's in his last year of study. Our research has one main objective: to promote the recent advancements in machine learning and to find possible usages, possible applications to improve the accuracy and the reliability of the data that is generated during medical screening. A few more words on the background and motivation. We are facing, during our study, during our project, we are facing some challenges. I'm speaking strictly about the region of the Balkans in Europe. Sometimes when we have manual data entry, we have inconsistencies, sometimes manual entries, and we have some reluctancy, to say the least, in terms of introducing standardization. We're finding that the role of machine learning will grow during the medical screening analysis because the ML models are able to handle such challenges, especially when large data sets are being processed and when some patterns need to be identified in the data that can be used for helping the decision of the medical personnel. Other than that, some more info on the challenges. The data that we use during the medical screenings sometimes reflects patient conditions, and not always you have medical specialists available who can identify them. So, introducing such tools may play a crucial role and may somehow serve to reduce reduce the gaps in the therapy, but on the other hand, it introduces some complexity. We find that improving the data quality should be our one of our main focuses, as I mentioned before, because we extensively used the Titmus V4 Vision screener. It's a fairly well-known device, and the manual entries that are required to bring this to bring the data from the medical screening was due to the poor quality and unreliable results by the manual entries. I talked about the various advantages of deploying the AI-based models that will overcome some of the existing problems. Some of them are caused also by the data variations, besides the manual entries. We are looking forward to improving the interpretability, and also we found that the interdisciplinary cooperation can be improved in a significant way. In terms of methodology for our research, I'm stressing here on some of the steps. The data acquisition, as I mentioned, the Titmus Vision Screener. This is the equipment that was funded by the research and is being used. I will show you the setup in a minute. Why this equipment was chosen? It allows multifunctional screening, and it is proven to have a fairly high efficiency. During the pre-processing steps, the data is cleaned up and it's formatted before the next analysis step. For the model training and evaluation phase in our methodology, we rely on the secure multi-part computation. This is a technique which we consider secure by design, and it allows for the machine learning models to be trained in decentralized and distributed ways. For this to happen, we require the data to be reviewed and carefully annotated by specialists. So we're for our research, our capabilities are focused currently to supervised learning, because we also don't want to exclude anyone from their healthcare role. So this is a brief overview of the workflow. Next, I'm going to show you the system architecture, where we have different roles, different ways to access this design system, and then some of the components that we're using. In terms of clients, we have envisioned the capabilities for a healthcare portal to be accessed by mobile applications, by mobile devices, via browser, or integrated, and we are also exposing secure API. Other roles that can access these systems are patients who would like to review their data, and of course, doctors who can be therapists and annotators. As you can see, we have in certain areas we have access to a blockchain resource. Especially, I'm pointing out that we need to have this during the training and evaluation phase and the distributed storage, where also the healthcare portal has this capability. I'll talk about the advantages of blockchain in the next slides. The setup that we have used is basically to conduct our experiments for the case study. We equipped, obviously this is an AI-generated image that is fairly accurate in terms of setup. We have equipped vans with the Titmus Vision Screener, where we have a workplace for a healthcare professional who conducts the data acquisition, the ophthalmological test, the screening on multiple people. Especially, I'm stressing that this is done in remote areas such as mountainous areas on the Balkans. If you are familiar with the geography of the Balkans, you will find out that this is a fairly underdeveloped area, which exactly requires this kind of mobility and access of the population to healthcare professionals. So the data is acquired, it is entered through the internet by this healthcare professional. At the entry point, we have anonymization. There is a special procedure which takes place. The data is anonymized. Then all the collected data has been annotated by participating ophthalmologists. What the outcomes were targeted. It was distributed, designed, and enhanced data processing capabilities, as I mentioned. Of course, coverage of remote areas. This is for us is very important. This was funded by various sources. Also, we gave during our project, we discovered that we need to focus on IoT capabilities. That means pushing the heavy lifting towards the edge AI, which means deploying some of the trained models on devices such as the Jetson Nano. We have access to such devices, and this brings a huge cost reduction potential. Some words on the model evaluations. I'm showing here a table for the accuracy of the trained models. We have trained quite a few models. I've listed a few of them here. And for a comparison, the maximum accuracy for a human trainer, for a human annotator, a human evaluator was about 85%. This was the top accuracy. As you can see, we have good, fairly reasonable accuracy for the evaluated models, and this is combined with a small, relatively small, I would say, model size, which enables us to deploy these models on the edge. So, a few more on the results. The benchmarking in the performance. We observed improvement on the baseline, which means the data entry was improved because of this, because some of the entries which had big divergence were returned for inspection to the healthcare professional conducting the test. Just as an example, the healthcare practitioners, the clinicians were greatly impressed by this improved data quality. This leads to more accurate diagnosis and treatments, and the reliability enhancement, which is, in our vision, using ML in order to establish a reliable source of truth. Some more on the main benefits. The scalability of that is achieved through the system, latency and performance by pushing towards the edge. We are reducing gaps in the data acquisition, data processing, and also bridging gaps in the treatment of certain illnesses, ophthalmological illnesses for this for the current study. Cost effectiveness, as I mentioned, I think I was clear on this topic. Security and data privacy. We are relying on a secure by design architecture with the secure multi-party computation. Also, the blockchain that we are using gives us the tamper-proof data storage that is absolutely required by all healthcare standards that are currently introduced. Also, a big boost for the maintainability and upgradability, and of course, flexibility in terms of application and deployment. What are the future directions for our research? I'm almost concluding. Sorry for taking so long time. We're going to improve the secure multi-party computation, especially in the storage and the file systems that are used on the cloud-based sources and on the edge devices. Also, the next challenge that we're facing is involving somehow the recent advances in the large language models and the retrieval augmented generations. That means involving agents for generative AI. Next thing that we are going to work on is to integrate an additional modality in the from the ophthalmological area. This is the retinal scan. We have already gathered quite a lot of data, so on, and you can expect our next research in this area, in this direction. We will target different types of medical screenings and even other sectors such as pharmacy, where they require precision in the data handling. Also, we are going to seek. Yes, I'm concluding. We're going to seek collaborative opportunities with other sectors. So this is the summary. I think it was. I think the most important part is that we're seeking to democratize the usage of AI in healthcare. Thank you very much for your attention. I tried to keep the time limit. I'm ready for questions now, and yeah, here are the references from the research. Thank you very much for your attention.
Okay, so let me have some questions to argue. So I'm not sure your research result. So it is you are implement into commercialized products or commercialized application.
We are currently not comparing to commercialized applications. First of all, our research is funded by government sources, which treats this current research as a proof of concept. So, in terms of standardizations, the evaluation of medical screenings is an area which is still developing. So, we are comparing mainly to human annotators. This was the target of our research. Next steps, as I said, we are searching collaboration with vendors, with other parties, where we can compare this system with other commercial products which are available. For the time being, I think this was the target of our research, and yeah, we haven't. This comparison is yet to come. Thank you. I hope I was able to answer this.
Okay, so the last question. So how about the overhead when you compare to the accuracy rate result? So you got some high accuracy results. And you didn't mention about overhead times.
The overhead times, it's a good question, and I appreciate this. First of all, the data, the format of the data that we are using, and the 12 labels I mentioned, I think I mentioned it, 12 labels that we're using, comes from this Titmus vision screener. So all the data is measurable there. And I would say the overhead time for training the models is one component. Since it is being done in a multi-party computation way, we're not training the data locally. We're sending it somewhere, and we're just downloading the result. But the clever thing here, I would say, is that we are relying on the most accurate model. We're downloading from the blockchain. We're getting the most accurate model, and for this, I would say it is worth that this happens. We're not collecting all the data locally and training it, but instead, when a new entry comes in, we already have downloaded this 100, 200 megabytes. I'm just speculating, 100, 200 megabytes, and then the result is already there for us, and we can say this entry that you have provided is too far away and cannot be classified, for example. So you have to go back and improve the quality. Or if it goes to a certain class, to a certain label with unexpected quasi probability, then you can refer it. This is the outcome for improving the healthcare therapy, for example. We're referring this patient to the healthcare therapist, to the ophthalmologist who will treat this patient. So we're automating this. We're bridging the gap between the screening and the potential therapy. So as you are aware, the population of the whole of Europe is becoming older, and such vision screenings will become extremely important, especially with the treatment of ophthalmological illnesses. Thank you. I hope I answered this question.
Okay, so my a little recommendation for your future research. So you have to declare about your research limitations about your data
Yes.
set, and you train to only sum of attributes. So you didn't
Yes.
mention and you didn't train about what kind of the question that you want to pre-screening for about some kind of disease to pre-screening to advise or recommend for the doctor in your next future research as well. Thank you so much.
Yes. Thank you very much. Thank you.
Monica ma'am, do you have any questions for him?
Yeah, I do have a question. Thank you for your presentation.
No question from
Um,
my end.
all right, can I go on?
Yes, I can hear you.
Yeah, thank you for your question. Please on that slide that has the accuracy. Can you the slide you just showed? Can you talk to? I just have two questions. Number one, can you make some comments about the class balance? Okay. In your data set, and then number two question is what limitations does your model face in real life deployment? Yeah, just comment about the class balance in your data set and then the limitations of the model in real life deployment. Thank you.
One of the limitations, thank you very much for the questions. One of the limitations I would say is that, first of all, you are bound to some certain, to use some certain library in the backend to use this type of classifier. I would say with the current technologies, this is more of an opportunity. This becomes more of an opportunity, which does not. You are currently not limited to using this type of classifier because for our current data set, we show that the random forest delivered very good results. For some reason, however, you are not happy with this type of classifier. You may have some kind of preference. Usually, I would rely on the highest achieved accuracy, which is visible, by the way, in the blockchain. So, as I said, you would usually use the best performing classifier, which has already been trained for you. However, if you collect some more data, and meaning if you are performing some medical screenings and you collect a lot of data, then you can rely on this system design to send this data anonymized, I'm saying again, anonymized, to the multi-parties, and then some of the other parties may yield a different classifier based on their backend, based on their proposition, which will deliver better results. So this limitation on one hand becomes an opportunity on the other hand. So I would say the classifier does not limit us it is currently not to be regarded as a preference, as a limitation of the usage. It is being regarded as a tool to improve the overall accuracy. And also how this technology can be used. The automation that we created was first to evaluate those classifiers, then to deliver a whole system that is able to classify this particular entry was with container technology, which means you're getting the backend delivered in a container. Containers like Docker, like LXC, and relatively standard backend, which is able to be packed in a reasonable volume, so you can download it and use it and make it usable. I hope I answered this question.
Monica ma'am,
Thank
do you
you.
have questions for him?
No more questions from my end.
Thank you very much.
Okay, thank you for your presentation. Now I'd like to call upon Abdullah to present his research on experimental assessment of the performance of meta-resonator-based band-stop waveguide filters fabricated with CNC milling and stereolithography methods.
Hello.
Hello, sir.
Can I share my screen?
Yes, sir.
Yeah, all the remaining presenters are requested to please be stick with the time limit.
Okay. Hello, everyone. My name is Abdullah Genç. I am work at Isparta University of Applied Science in Turkey as a associate professor. Today, I would like to make presentation to you about the waveguide filter, and in our project, we design novel configuration by using two type of manufacturing method. These are CNC milling and SLA method. First of all, my presentation start with definition of the passive microwave component. Then I talk about the differences between conventional waveguide filter and meta-resonator based waveguide filter. Then I would like to show you the design of our waveguide filter, and I give information about the fabrication, simulation setup, measurement setup, and also the result. First of all, what is the passive microwave component? As you know, microwave passive components are essential element in the microwave circuit system. During my PhD and after my PhD, I deal with the design and fabricated different type of microwave component, such as T-junction, waveguide, antenna array, and coupling, something like that. Right now, I am doing a project which is supported by a national scientific institution called TÜBİTAK in Turkey. And this conference paper consists of some part of the art result of project. This kind of fabrication method has advantage such as rapid prototype, low cost, and complex design and low weight. And waveguide filter is used in many different areas, such as radar and space application. Actually, waveguide filters is the one of the example of the passive microwave filter. Waveguide filters are two terminal circuit elements that produce a frequency response according to the input signals. They are preferred due to their high power capacity and low power loss. When you compare the coaxial cable or microstrip line. That's why when you examine and investigate studies in the literature, different type of filter used in literature. These are Butterworth, Chebyshev, and Bessel filter, and mainly conventional waveguide filters classify in two parts. First one is iris type and post type. As you see on the picture, top left here, iris type of waveguide filter, and this kind of filter is designed by using post type. Actually, in literature, there are many studies about that. I didn't study conventional waveguide filter, but in order to introduce basic formula and introduction, we should know the conventional waveguide filter. But in our project, we dealing with meta-resonator based waveguide filter. This kind of filter is more advantage than other type because these are easier to model equivalent circuit compared to conventional type. And also meta-resonator based waveguide filter also provides negative electrical and magnetic permeability. This is more advantage, and we can make smaller their size, also low cost. In our project, we design many type of meta-resonator by using some substrate which is called Rogers 5880 type of, and we design different kind of geometry. For example, ring type, rectangular type, and other one. These meta-resonator classify in two. First one is SRR, which is means split ring resonator. If you would like to design a band stop filter, you have to use SRR type. But if you want to design a band pass waveguide filter, you should use to CSRR meta-resonator type. This is the main differences. Also, in order to show the performance of the filter, you get information about some parameters such as resonance frequency, also bandwidth, also quality factor, something like that. And also this is the formula because every type of meta-resonator has equivalent circuit as like L and S circuit. By using this formula, it is easy to specify conductive and inductive value. This is our novel design. Also, by using this design, last year we applied patent application in Turkey, and actually we only in this project we only use just one waveguide structure. This is waveguide structure, and we can change just meta-resonator geometry or type, etc. By changing meta-resonator, it is possible to design different type of waveguide filter. I mean multifunctional filter. For example, Alternatively, by using a single waveguide structure, resonance frequency can be adjusted by changing the geometry of the SRR metaresonator, and also by using SRR or CSRR, we can design any of them band stop or band pass filter, and also we can specify filter order by changing number of the metaresonator. For example, in our design, as you see, there are 7 split. If you edit this metaresonator in the split, we can change filter order. And also narrow and wide band fit filter is possible. For example, if you use rectangular type, it is very low bandwidth filter. But if you use other type geometry like ring or cycled resonator, we can extend its bandwidth. And also, as you see, this is the design. During the project and our design, all simulation are carried out CST Studio commercial program. By using this program, we design all the simulation configuration setup. This is also the design parameter of SRR metaresonator. In this conference paper, we design band step filter, but we use 2 kind of manufacturing techniques. Basically, in this study, a band step waveguide filter in C band is designed, fabricated by using 2 different methods, and the effect of the fabrication method on the filter performance is experimentally and numerically together evaluated. And filter order for each case increased from 1 to 7. Let's look at the fabrication that we dealing with. Actually, firstly, we design CAD model by using SolidWorks, and then we make simulation for this design in CST. Then we pass other step. First design, we use CNC method. In this method, all the component is fabricated aluminum 7570 aluminum types. Then other type of filter is fabricated by using 3D printing fabrication method. Actually, the main motivation of this work is compare the performance of two types filter. In the CLA 3D printing fabrication, filter fabrication obtained using 3D printing method takes place in 2 stages. As you know, we have covered all the surface inside the waveguide with metal. First stage is by using liquid resin. This CAD model is fabricated by using SLA 3D printer. Then we pass a metal coating process. All metal coating process are carried out by spraying method. Finally, varnish is applied to prevent oxidation. Because if you use this filter more than 5 or 6 years, it should be prevented on the surface in order to prevent oxidation. And
Yeah, dear researcher,
sorry.
Sorry for the interruption. You are requested to kindly conclude your presentation. You
Time
have
is up.
already crossed the time limit which is being provided to you.
Okay.
Kindly conclude fast.
Okay. This is the last step is measuring setup. By using a vector network analyzer, all the measurement results are obtained. Then we have the result. We compare the result. All result is getting from the simulation and measurement. As you see, simulation and measurement result have a good agreement with each other. In general, performance of the CNC fabricated filter is better than that the CLA fabricated filter in all orders. But best choice, as we expect, is came from the simulation result. And also all filter design in the study center frequency is of 6 gigahertz, and are the bandpass filters with approximately bandwidth approximately is from 6 to 7%. Also from filter order 1 to 7, we didn't put all the result, we just put some of them, and we compare the performance result. As you see, the performance comparison of the proposed bandstop waveguide filter is very good, because we also compare the result with commercial waveguide filter, which is important for us, because the main target and aim of the project is to design and fabricate it with same performance and characterization with the commercial one. Lastly, I would like to thank you, TÜBİTAK Scientific Technology Institution in Turkey, because financially they are support us. Thank you very much, all of you, for listening to me. Is there any question I can try to answer?
Yes, thank you so much for your presentation. You have nicely presented everything. My question is, what are the challenges in manufacturing high frequency waveguide filters? Challenges in manufacturing high frequency waveguide filters. If you can throw some light on it, please.
Okay, thank you very much your question. Your question is very good, because our limitation in terms of the fabrication is that we facing some problem because of manufacturing tolerance. For example, you can see the waveguide structure here. We produce this structure more than 5 times because of the fabrication error. And second limitation is that in order to produce this metal resonator structure, we use LPKF devices, which is very expensive devices. For example, accuracy in terms of the fabrication is important for the metal resonator. For example, if you etched this kind of material like 0.1 millimeter error, the result changeable. That's why it is too sufficient and important to produce in low tolerance, both for waveguide structure and metal resonator. That's why the budget of our project is a little bit high, to produce high quality waveguide structure. Can you hear me?
Yeah, no more questions from my end.
Sir, do you have any questions?
I have no questions.
Okay, thank you, Abdullah sir, for your presentation.
Thank you very much.
Now, next up, I would like to call upon Biswadeep Sarkar to present a study on hybrid Finbert LSTM deep learning framework for stock price prediction, a sentiment analysis approach using earnings call transcripts. Sir, are you present?
Yeah, hello. Audible?
Yes, sir.
Yeah,
And
okay.
also, I would kindly request you to adhere to the 12-minute time limit, please.
Yeah, sure. Can I share the screen?
Yes, sir.
Okay. Is my screen visible?
Yes, sir, it is visible to us.
Okay. Good afternoon, everyone. I am Bishwadip Shorkar, a product management and data analytics professional. Currently, I am pursuing a master's in financial technology at the National College of Ireland. Today, I am excited to present my research titled Hybrid Finbert LSTM Deep Learning Framework for Stock Price Prediction, a sentiment analysis approach using earnings call conference. In simple terms, we have used sentiment scores from corporate earnings call transcripts to improve stock price prediction. I would also like to take this opportunity to thank my professor, Dr. Abdul Shahid, for his invaluable guidance. Now, why stock price prediction? Stock price prediction is a critical research area with significant economic implications. Investors, traders, and financial institutions rely on accurate prediction for informed decision making, risk management, and market efficiency. With advancement in AI and natural language processing or NLP, we can now integrate textual data such as news articles, earnings call transcripts to enhance the prediction accuracy. Let's understand what is earnings call. Earnings calls serve as a crucial communication channel between corporate leadership and investors. These calls provide transparency on financial performance, business strategy, and market outlook. They typically consist of three main components: management presentation, where executives discuss revenue, profits, and strategic discussions; financial performance review, where companies share key financial metrics and future projections; and in Q&A session, analysts and investors ask questions about company performance, risk, and outlook. Now, why it is important? Earnings calls are crucial for three main reasons: transparency and trust, as they provide direct insight into a company's financial health and strategy; market impact, corporate announcements influence investor sentiment and can drive stock price fluctuations; and regulatory compliances, as they ensure fair disclosure of financial information, preventing insider trading and maintaining market integrity. Now, on prior research and key studies, traditional stock price prediction models have primarily focused on historical price and numerical data. However, recent studies highlight the importance of textual sentiment analysis in forecasting stock prices. For our research, we reviewed more than 20 papers, and here I would like to highlight three key studies shaping our approach. So, Martel work helped us determine parts of the transcript which are more relevant for the sentiment analysis. Huang et al. Developed Finbert model trained on particularly financial data, enhancing sentiment extraction and accuracy. And Gu et al. Introduced a Finbert LSTM hybrid model using like news articles, reinforcing our decision to further explore this approach. Now, coming to methodology, our approach combines Finbert for sentiment extraction with LSTM for price prediction. As you can see on our screen, we started with 18,755 earnings call transcripts and then processed them to remove the redundant data. Then, using the timestamp of each call, we determine the last market closing date. So, if the call happened after market hours, we use the same day's closing price. Otherwise, we took the previous trading day's closing price. We fetch the historical stock prices from Yahoo Finance. We then applied Finbert to extract the sentiment scores from the transcripts. The sentiment scores were then integrated into the LSTM model, which we compared against a standalone LSTM to evaluate improvement in prediction accuracy. Let's now talk about the results. We conducted this experiment on 6 major finance and tech stocks, namely Citibank, Meta, Visa, Microsoft, Autodesk, and JP Morgan Chase. And in our key findings, Citibank and Meta achieved a significant 38% lower mean squared error with sensitive sentiment analysis integration, and Visa and Microsoft also showed improved prediction accuracy. However, as you can see on the table, the standalone LSTM model performed better for Autodesk and JP Morgan Chase, suggesting other factors influence these stocks significantly. Now, to conclude, this research aligns with Sustainable Development Goal 9 by leveraging AI for financial decision making. Our findings show that sentiment analysis improves stock price prediction for companies like Microsoft, Visa, Citibank, and Meta. However, traditional models still outperforms. Some cases highlight the need for further enhancement. Moving forward, we plan to expand the model scope to incorporate market cap, trading volume, sector, and microeconomic trends, enhance the NLP techniques to improve the sentiment extraction for better accuracy, implement a real-time stock prediction for traders, apply this model across diverse industries to validate findings across multiple sectors. Thank you for your time. Now I would love to hear your thoughts and answer any question.
Yes, Vishwadeep, nicely presented. I have one question that you didn't include the literature review in your presentations. So, could you please throw some light about your literature review?
Okay, so we have studied more than 20 papers for the literature review, right? And as you can see, we have highlighted some papers here, the top 3 papers, which has, like helped us to shape the our research.
Yeah. How did you come up with this algorithm which you are using for your model?
Okay, so in this when it comes to as you can see, so there are 2 segments, right? Like historically, like stock price prediction is a well researched area, right? And previously there has been many studies where historical prices and other features are being studied for stock price prediction, right? And with advent of natural language processing, sentiment, like textual data are now being considered for several other studies. As you can see, I have included a chart how we came up with this, like so there are RNN models which are now largely being used for prediction, and on the other side there are several NLP models which are
Yes, so
NLP.
you are advised to kindly include those comparisons also. So you need to throw some light on the algorithm which you are using. So that how did you come up with that particular solution, conclusion that you are going to use that algorithm for your further research? So you need to have the answer regarding that also. So you need to include that particular slide in presentation.
Oh, okay, sure. I will take that advice and I will add that in future.
Sir, do you have any questions for him?
No, thank you.
Okay, thank you, Biswadeep, for your presentation.
Thank you.
Now, next up is Italo Santos to present his study on the capacity of representation of an e-nose constructed with 2 MOX sensors.
Can you all hear me?
Yes, sir.
Okay, so let me just share my presentation real quick. Everyone can see the presentation clear?
Yes, sir. Your presentation is visible.
Okay, thank you very much. Good afternoon to you all. My name is Itulo Santos. I am a master degree student at the post-graduation program in electrical engineering at the Federal University of Sergipe here in Brazil, and I'm also part of the research group Bia Chaves, and together with Jugurta Montalvão and Luis Miranda, we worked on the subject that we called on the capacitor representation of MINOs constructed with two Mach sensors. So to start, electronic noses or e-noses are devices that are basically constructed as an array of different volatile gas sensors, generally coupled with temperature and humidity sensors as well. And they present a multivariate time series response to the presence of determined gases present in the ambient, as we can see exemplified here in this graph. So they were employed in already many different applications, be it in air quality analysis, aid on disease detection, food and beverage quality assurance and discrimination, detection of pollutants, and many other applications. And there are many different types of gas sensor technology that exist. I'm going to focus the conductive sensors, more specifically on oxide or the Mach sensors, because these are the ones that are most used nowadays, given their lower cost, the fact that they have a simple construction, that they are portable, and they have a high sensibility. But they come with cons as well, with some problems that are the high sensibility to temperature and humidity. They suffer from short-term and long-term drift, and they present a low selectivity. And this last problem is actually the problematic in question that drove us this work, because this lower selectivity actually implies that there could be redundancies between these sensors. And then we can back the question of what is the capacity of separation of, for example, classes when we use these signals in pattern recognition tasks, for example. So if we scale the amount of sensors, we would increase the cost, the complexity of these e-noses, and at some point we would hit a diminishing returns point. So it would be very interesting to have a way to estimate the capacity of representation to assess and to compare these different constructions of the noses. And to this end, we demonstrated this using actual simulated data, using validated models from the literature of steady-state responses of these Mach sensors, ignoring the drift effect that happens. So the objective of our research was to propose a quantity to determine the capacity of spaces generated by Mach-based e-noses to represent different concentrations of gas mixtures. More specifically, we wanted to answer the question, how many different combinations of gas mixtures can be separated with an arbitrarily small error of classification between them? So our work borrowed a lot from the information theory presented by Claude Shannon. So if we see here a noisy channel, we know it is known that when we have a source that is sending a message, this message isn't necessarily what we're going to get in this destination, especially if we have a noise source that corrupts this channel. So it is known that for a noisy channel, the channel capacity is given by the maximum mutual information between these two quantities. And it is known as well that the mutual information can be given not only using the entropy of the source, but the entropy of the destination as well. So the parallel that we wanted to bring here is that we can imagine the idealized responses of these sensors as an input of this system, and there is an equivocation, a corruption that might occur, and we can imagine this corrupted sensor responses as the destination. And well, in an analogous way from the channel capacity, we can imagine a representation capacity that tells us the limits of this structure that is basically the responses of these sensors. And in the same way, we could imagine if we manage to estimate these measurements of, for example, the differential entropy of these structures here, we might finally have this measurement. So The representation capacity estimation that we are proposing starts with the following steps. We estimate the intrinsic dimension in the differential entropy of that corrupted structure. We need to characterize the noise that affects the sensor arrays. We need to understand them to then be able to estimate its differential entropy. And then we can finally compute the mutual information of those two estimates. And if these estimates are given in bits, so we can make 2 to the power of this calculation and write down the values. So we actually demonstrated this using simulations of idealized responses for 2 virtual sensors using validated models from the literature of steady state responses. And we limited it to a specific range of mixtures of ethanol and acetone where those models were validated. So as we can see here, we have a projection of a space composed of concentrations of acetone and ethanol mixtures to the space of sensors, and specifically 2 mock sensors that were simulated. And these values are actually given in the ratio of conductances, but generally we need to condition these informations into voltages and generally we use voltage dividers and other kinds of circuits for this end, and we ended up with voltage signals that are related to the responses. But well, these are the idealized responses of the sensors. But we still need to understand how the noise actually affects the sensors to understand how the equivocation happens. So we asked some questions. Does the noise change with the gas concentrations present in the ambient? Does the noise have any memory elements if it has any temporal dependency? And if the noise between sensors have any dependency between each other? To answer these questions, we had to rely on actual real data that was collected in the control environment, and we extracted only the noise present on these data using mean square error. And then for each of the conditions that we tested, we conduct some methodologies here. For the dependence on the concentration, we estimated the variance of the noise over time using the applied correlations. For the time dependency, we use the generalized correlation function, and to test the interdependency between the noise, we used intrinsic dimension estimations and correlations. And the conclusions from this is that there was no dependence of the noise from the gas concentrations, but the variance of the noise was actually variable over time. There was no temporal dependency between the noise instances, and there was no dependence between noises from different sensors. So with that, we characterize the noise as the type additive of the type Gaussian, with a variance at the order of magnitude found on the real data that we just used. And then the differential entropy of the equivocation will be given by the entropy of this noise that we used. So basically, we can finally finish our simulation where the idealized responses as the input are going to be corrupted by different levels of noise, and we can finally have the output of the system. And we can apply those procedures to estimate our capacity representation. So for this level of noise here, we had these 2 estimates for the differential entropy using methodologies present in the literature, and we ended up with 33 pairs of concentrations. What this means is that from the infinite combinations that could be represented by those sensors, because of the natural noise that happens when we make measurements using them, only 33 pairs of concentrations can actually be separated with an arbitrary error, arbitrary small error, sorry. And not only that, we can see that for increasingly levels of noise, we can see that the capacity gets lower as well. And we conducted another simulation as well, this time to understand how the confusion error happens. So basically, we selected the region for the responses of these 2 sensors, and we used a vector quantization method algorithm, the k-means, ranging the k from 1 to 100, so that we can partition the structure here, and thinking about using only the selected centers as the information that we would give. And when we conducted a Monte Carlo method to estimate the confusion error after we sampled each of these centers, and we corrupted them with the noise that we applied before. And with this, we actually can see here in this plot that the error, the confusion error, this classification error, starts to increase even before the representation capacity that we estimated. And we believe that this happens because, well, this classification is happening with only one sample at a time. And generally, when we think about the channel capacity, going back to Shannon, we you generally see it for the I forgot the name of it. Sorry. So the typical sets, yeah, sorry, for this typical set. So we think about larger and larger amounts of symbols. So that's a reason for this. And well, we use the k-means as a vector quantizers, and because of this, it probably wasn't the perfect codification of our space that would bring us the error even lower. But, well, to reach our conclusions then, we presented a novel statistical quantity, the representation capacity, and we demonstrated its estimation for two validated virtual sensors. And this estimation can actually be expanded upon if we actually model other MOX sensors. The representation capacity depends on the noise level that affects these sensors and how widely these sensors respond to the gases, because it depends on the actual effective volume, the effective area of the structure that it is spanned by the sensors. And due to the nonlinear nature of the projection from these concentration spaces to the sensor, we believe that the capacity estimated might be an overestimate of the actual representation capacity. And the hypothesis that we have is that this capacity can be both used in controlled and uncontrolled environments if enough time is given to statistically learn the signal structure. And the next steps for our work would be to develop a new data set for different gas mixtures to be able to assess this estimation using actual real data, and to be able to see how scaling the number of sensors would affect this quantity. And to finish, we believe that this quantity would be useful to understand how different Mach sensors and even other conductive sensors could contribute to the construction of these e-noses for pattern recognition systems. So here are the main references that I used, and thank you very much, and I'm open to any questions.
So, do you have any questions for him?
Person no.
Okay, thank you, Italo, for your presentation.
Thank you very much for your attention.
Okay, sorry, Chris Wet. So I'm not sure about your research. Is only explains how you is your research study or focused or exploring or only study to explain what is the mechanism to evaluate the gas mix model? It is right.
Sorry, could you repeat?
So I'm not sure what is your research contribution is only focused about you just want to study to compare the protocol or mechanism to evaluate your model. It does not extend to the academic contribution.
So we based on our work on very well developed theory from information theory from Claude Shannon, and we believe that our contribution would be to have a way to have a theoretical limit to the capabilities of the sensors that are already widely used in many different aspects. But actually, the one aspect that I didn't mention is that, for example, the intrinsic dimension of these electronic noses are generally very low. So even though we can use up to 10, 15 sensors to analyze them, generally the intrinsic dimension, the structure where the actual data sits, it's a lot lower. And then this corresponds to a lot of redundancy. So we propose this as a way to actually measure the contribution of each of these sensors to these arrays in a more broader way, not specifically thinking about one application or other. I hope I answered the question correctly.
That's why, and I have not enough the understanding to under your research field because you didn't shows about the accuracy for validate the model. So that's why. So for next your research, so you have to give to the author more and more details about your accuracy rate or like more increasing your accuracies in your research
Okay,
results,
thank you.
like the hypothesis test result. That's why. Thank you so much.
Okay, thank you. Thank you very much.
Thank you. Now, next up, we have Elvin Eziyama to present their study on safeguarding autonomous transportation, deep learning strategies for detecting anomalies in vehicle sensor data. Are you present, sir?
Yeah, I'm here. Please, can you enable me to share?
Yes, sir.
Can you see my screen?
Yes, sir, we can see your screen.
Okay, thank you. Just one moment. Okay, thank you, everyone. Eziama Irvin. I happen to be an assistant professor with Goma University. So today I'm here to make a presentation on our work on safeguarding autonomous transportation, making use of deep learning strategies. And then this is more or less the outline of my presentation. Now, as we all know, the idea of a connected autonomous vehicle is such a technology that is more or less revolutionizing the intelligent transportation today. But then this advanced technology comes with some attendant issues like issue of vulnerability as a result of, securities, just because of the fact that there are a lot of interactions with as a result of a force injection attacks and then sensor interference. And then in our study, we actually propose techniques of DC wavelet transform combining with deep reinforcement learning. And then our model was able to enhance the security nature of the connected autonomous vehicles by capturing most of the distant anomalies in our experiment. Now, the problem segment, we actually have, increasing dependency of CAVs on sensor data, and this actually makes it to be quite vulnerable to cyber threats. And then we see that most of the models in the literature actually struggle to detect some of these attack methodologies in CAVs as a result of the fact that most of them don't really scale, and then they're not just adaptable. And then we have the issue of false positive and then sensor interference that lead to anomaly detection. So in our approach, we're able to develop a robust and adaptive approach that really helps us in capture most of these anomalies in the CAV network. Now, our proposed model, we actually made use of techniques like the district wavelet transform that really helps us to denoise the sensor readings. And at the same time, we incorporated in our model deep Q network that dynamically, helps in dictating all these anomalies. And then this integration of the deep Q network and then discrete wavelet transform actually helps to minimize the false positive in our computation process. And then our approach, significantly improve performance over the conventional real-time dictation. Now, in our work, we're able to compare our model being the discrete wavelet transform combined with that of the deep Q network with some of the conventional state-of-the-art models like the CNN LSTM, the one classifier CVN, and then LSTM combined with that of autoencoder. So we find out that our model consistently achieve a very high F1 score. And at the same time, it was able to reduce the false positive and then the negative content when compared with the existing methods. Now, these are some of our results. So we actually, in our model, we consider different attack rate, whereby we configure some percentage of the attack in the system. So in this regard, we have about 3% of our data being configured to be anomaly and then subject to our proposed model. We find that our model was able to, outperform more than the baseline models. Then we forge ahead to compute the computational complexity, though there's a little bit complexity issues with respect to our model by having about 4 GB footprint. But then the trade-off is something that is very much encouraging when compared with that of our accuracy techniques. I think now our limitation happens to be the issue of computational complexity and then real-time processing constraint. So in our conclusion, we actually presented a novel approach that helps in enhancing cybersecurity in transportation sector. And then our model was able to, outperform existing methods in the literature. And then we have in mind of incorporating the idea of multimodal attack data set and then see how best we can actually improve the computation efficiency in our future research work. So in conclusion, this research actually paved way for secure and reliable intelligent transportation. Thank you for your time. I'm just willing to accept any question.
So I have some questions. So please go back to the research result. Okay. So no, in next slide.
This.
Okay, this. Okay, so I was very confusing. So what is your recommendation to implement for the commercialized products? Because
Okay, thank you.
I saw of this DWT is very high and prediction times is very high too. But
Yeah.
CNN extremely high, but accuracy time is more. But I'm not sure for your research result is contribute such a good one and when you're comparing to the accuracy or overhead times. I'm not sure which one is the best for your research.
Can you come again, please?
I'm not sure what your is recommends for the research. It accuracy, high accuracy, or high overhead times when you
Yeah, my recommendation is just on the high accuracy, but we have in mind in our future work to see how best we optimize the model, more especially the discrete wavelet transform that comes with a lot of features and that result to the computational complexity. So we have in mind of decomposing the multi-level structure of the discrete wavelet transform to accommodate to reduce the latency in the computation.
So what a good choice for implements or critical implications.
You mean in real time?
No, so I mean like for next step to implement to the commercialized products.
Okay, just like I rightly said, we have in mind of optimizing the model by first of all tackling the issue that as a result of the discrete wavelet transform that result to the high computational complexity, and then at the same time bringing in some other optimization techniques like the genetic algorithm that can help us in doing a feature selection. With that, we can actually reduce the computation complexity for possible deployment in real time.
What is your research limitation?
Yeah, the limitation is just all about the computational complexity and then the issue of model convergence as a result of the discrete wavelet transform. And just like rightly discussed, the issue of a real-time processing constraint, given the fact that we are considering connected and autonomous vehicles that requires low latency. So these are some of my limitations.
Latency. Okay. Oh, thank you so much for your good answer.
Okay, thank you.
Thank you, Edwin, for your presentation.
Okay, thank you very much.
Now, as we reach the closing ceremony for this session, I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I also would like to thank our session chairs. Thank you, Dr. Kanakan Panipong, sir, for gracing us with your presence for this session. And I'm extending a token of appreciation on behalf of Team ICICT 25 and Global Knowledge Research Foundation and partners. Sir, do you have any closing remark for all the presenters that were there today?
Okay. For me. Okay, so
Yes,
thank
sir.
you for having me. So many articles so make me surprised and what very surprised about your presentation showcase cutting edge advancement augmented rarity in education, AI driven medical screening, deep learning frameworks, and a special appreciation go to our organizing committee, technical teams, and all participants for your active engagement, and which made the session truly dynamics and insightful, especially the session chair, Professor Monica. She have a good advice and good question to share to the everyone. So as we move forward, I encourage you, each of you, to take the inspiration from today's discussion, explore interdisciplinary opportunities to continuation practice, bodily to technical innovations in the future. Once again, thank you all for being a part of these sections. I look forward to seeing you in next year conference and collaborations as well. Thank you so much.
Thank you, sir. And I would also like to thank Dr. Manika Rathod for being a session chair. I'm sharing a token of appreciation for your valuable presence, ma'am. Ma'am, do you have any closing remarks for everyone present here?
Yeah, thank you so much for having me here as session chair. I thank to organizing committee and my co-chair, and thank you so much to all the presenters for their enlightening presentations. Thank you so much.
Thank you so much, ma'am. Now, as we reach the end of the session, I would kindly request all of you to switch on your camera for a quick snapshot of the virtual conference. I repeat, everyone please turn on your camera for 1 minute. Okay, thank you so much, everyone. Have a great day ahead and take care.
Thank you so much. Have a great day.
Thank you, sir.
See you next year.
Yes, sir, definitely.
Bye bye. Bye bye.